Fire escape engineers inspector summary video. We're here in Rutland, Vermont. Here we got a fire escape on a school. A couple things. We're here to find out whether or not we can certify or load test this fire escape based on this inspection. And it's not ready for an inspection or a load test. A couple of issues with this fire escape, and once those issues are resolved, we can proceed immediately to the load test and get you the guarantee. Otherwise, we can spot repair this fire escape and do the load test, or we can change all the major structural issues that we're about to talk about and reinforce them, and that avoids the load test. So let's start right here. We got a fire escape that first of all has got tons of rust, and it looks like it's older than 78, and it's lead based. So you have to have an EPA renovator's license to touch this in order to scrape it, because there's lead based paint. Number two, let's talk about the railing. The railing is a non-conforming rail. The easiest situation here is to take this rail out and just put in a standard rail, or utilize this rail and put mesh behind it in sort of a frame, because we can't weld. Once you have lead on a fire escape, you can only use bolted connection, but it's a very weakened rail. So you could probably make a frame in the back, get this thing to hit 42, and put the mesh along the back, because the rule here is very, very wide, and it's no more than 4 is to make it current, but this in its day is also excessive. I think this is almost 8. So these holes, this is just too big. So we need to basically put more bars in here, but because you can't weld, the best answer is a box of mesh on the back side, including going down the whole rail once you straighten it out. And that will allow you to continue using what you got here. Again, to scrape this fire escape, you have to have an EPA renovator's license because of the lead. Now let's talk about it structurally. What we have is a big monster fire escape that looks like it used to be a cantilever, because there's the pivot right there, which I'm going to go into detail. This used to be in the air, and then they removed the weight box or whatever was here, and this is just one long stair. Speaking with a city official, I'll determine whether or not this is too long for them, or if they want to create a break, then a stair down to the ground, or if they want to cage this if they're having problems with break-ins here. But let's continue down what we have. We have all welded connections. Every time you have a welded connections, I need a bolt. I have to either x-ray or load test every weld. But as soon as I bolt it, I don't need it. So see all this welded connections? It's probably rotting from the inside out, but as soon as I put some bolts through here, put an angle clip here and bolt it here and here, I can keep that weld, and I don't have to verify it anymore. That goes for this side too. So good, whether the weld is good or not, the x-ray would tell me, but that's very expensive, or the load test would verify. I put in some bolts, done. So every welded connection needs to be backed up with a bolt. Every single one of these treads is welded. Every single one. Problem is, if you don't maintain these welds, they rot from the inside out. So we need to put in some bolting or some angle clips underneath here, and basically seal these during the paint process with the silicone, and then underneath I would put in a 1-inch angle clip with bolts. The bolts are going to guarantee that these treads are not going to fall and go anywhere. Every single one of these railings is welded. So these are the minor structural. So we need a post, an intermediate post. Probably usually every 5 treads you're supposed to have a post on both sides. So those posts plus the mesh on the outside is going to resolve this issue of this welded rail. So it's an all welded fire escape. Here's my pivot. So this is an indicator that this cantilever was up in the air at one time. Oh, I know it. I see it right here. So it looks like they removed the weight box out of the back. So we need to find out what they want to do with this, whether they want to modify the existing structure, and if it's going to stay as an as-is structure, whether or not they want to cage it or they just want to leave it as is, and we'll close it up, straighten it out. But definitely needs mesh on the outside railings, mesh, and everything that's a welded connection needs to be backed up with a bolt. And We need some posts here, 2x2 angles or 2x2 or 1.5 posts, anywhere just to stiffen this whole baby up, including the rails up above. Massive I-beams coming out of the building is more than sufficient to hold this thing strong. I'm sure they're buried well deep into the building, but we just need to verify just what the construction was of this. And then again, back to the scraping and the painting. So this fire escape, an all welded fire escape, is going to need to be x-rayed, load tested, or if we can reinforce and refurbish every one of these welds, silicone shut, scrape and paint, this fire escape will not need a load test. And again, and mesh all the rail systems so that we can meet the 4-inch rule. Any questions? This is Fire Escape Engineers, Inspector Meneses here, 866-649-0333, 866-649-0333.